Hey Bart, all good to start.
All right, thanks. All right, welcome everyone to this webinar about vibration monitoring for blasts, protecting critical mining infrastructure and nearby communities. I have the pleasure to present that with my colleague Javier Ilianes as a senior product specialist in Australia from Orica Digital Solution. And I'm working at Syscom Instruments for the vibration monitoring devices based in Switzerland. So let's begin with this webinar, and feel free to write your questions on the chat. And this webinar will be recorded, and you will receive a link afterwards after this presentation. We'll start with a short introduction and objective, then some blast vibration monitoring, especially related to some standards and overview of some products, some instruments and example for installation with far field, near field, and underground example that you will have a look, and how it is then integrated with EnviroTrack software platform that will be presented by Javier with one case study and conclusion. So basically the challenge for open cut underground mining is really to have the best efficiency of the mine, the best yield of the mine. And for that, the idea is to increase the mineable areas by following the mine design, and also by generating high volume blasting to optimize the operational time and avoiding, the removal of the machinery during the blast and bringing down all the machines back in place post blast. So that's the trend with bigger blast, bigger and higher volume blasting with much more ore to recover during each blast. And another idea is to have very steep slopes to avoid generating too much waste and having large tailing storage facilities for that. But the problem with that is that generating bigger blast may generate also higher vibrations, and having steeper slopes would have a direct impact on the slope stability. And we would like to avoid, obviously, what's on the right side, the picture on the right. And to mitigate these kind of things, key thing is the mine security. You would like to avoid a closure of the mine, obviously, and protecting your people, your equipment, and also manage the risk associated to what we discussed just before, having steeper slopes, more vertical walls, benches, and so on. So for that, one possibility is to have real-time monitoring equipments, and obviously in this topic today with vibration measurement monitoring solutions, but it could be linked with the geotechnical crack gauges, radars, INSAR techniques to have a complete overview of what's happening on your mining site. So both works together, and it's also followed and by different measures to put in place. And the first one is the compliance to local international standards. Doesn't mean that it's going to prevent any failure. That would be the analysis of the data that would help and support these kind of things. But having standards would at least give a perimeter to install instrumentation and justify that it's worth the risk and the safety measures in place. Obviously, we'd like to control the vibration levels on site, especially also for surrounding structures and communities to avoid big legal issues, and also still keep the vibrations and the blast induced vibrations in a specific parameters that would not be exceeded and was probably negotiated with communities. So all in all, this is firstly managed by main international standards, and this is pretty basics in the end with the vibration related standards. It's just comparing the PPV. So PPV is peak particle velocity that is measured by a geophone velocity sensor, and compare that to defined limits by regulation. So the first one is the ISEE guideline. It's typically the International Society of Explosive Engineers guideline, and that's a graph that you may be familiar with, comparing the blue, dark blue and orange curves to the green values here, that would be the measurement done for a blast. There is also the DIN 4150 that is widely used with different categorization of buildings. First one being the lowest acceptable limit for historical buildings. Then you have the black curve with residential building and industrial building at the top that would accept a higher tolerance to vibration. And main parameters there are the full range of the sensor and also the frequency range. So on the mining site, there are four challenges, basically the blast zone with the blast design and execution. You would like to optimize your blast, and monitoring vibration would will help improve the blast design and also the energy dissipation and so on. So you can fine tune your blast with the vibration monitoring. Then there would be environmental and compliance monitoring. So this is what we just mentioned before for surrounding communities, sensitive equipments around the mining site. We'll see an example after, to mitigate vibration and probably design also the blast to try to disrupt the operations that would be beside the mine. Then there is also a possibility for underground mines, and especially with maybe wireless detonators that are being used more and more, with blast hole verification, where you can use vibration, blast induced vibration to detect if the detonator was fired properly, if there is a misfire. We'll see an example also afterwards. And all aspects related to the geotechnical and earthquake monitoring, especially for the tailing storage, where it's built and stacked one on top of each other, which would maybe not bring the best stability over the tailing structures. And these kind of vibration equipments may be able to measure shear velocities and also detect early failures in the slope stability, and that would be also associated to earthquake risks. So these four applications would be what is possible to monitor on the mines, really related to vibrations, and we would like to more or less optimize all these four to have a better mining efficiency, better yield of the mine. And this would be done with a fleet of sensors with several products that would be tailored for specific applications. But when we look at this kind of boxes, often you have a velocity sensor with an air pressure microphone, and it is typically what you are using currently on most of the mines. Especially to monitor and understand what's happening post-blast, and also, of course, during the blast. There are a few other devices and different type of sensors that would be for more specific applications, but that to mention that we have a full range of instruments. When we look more into details for the MR3003 BLA, so it's a motion recorder with an air pressure microphone and a geophone triaxial sensor for blasting, BLA for blasting. And this one is mostly used for far field measurement with air pressure when it is required, obviously with the microphone. And the big plus with these devices that they are built really for remote real-time monitoring. So it embeds a lot of communication technologies. Obviously, the purpose being you monitor permanently 24/7 what's happening on your mining sites for blasting induced vibrations, but also for all the other vibrations happening on site for better understanding of your mining and maybe rock mass structure, etc. So that's the first one. And a second one that is similar, but also for far field, but without air pressure, is a device that is completely autonomous with a small solar panel and very small footprint and all-in-one devices. You see compared to the previous one, right, where you have a few accessories and equipment. This one is an all-in-one box with edge computing where you can automatically transfer the data to a cloud platform. And Javier will explain a little bit further about that and how to process the data and the workflow from the device and the acquisition then to generating data-driven decision and insights on your site. This is connectable by 4G, and the process is, again, very easy to put in place and very straightforward. Last one that would have a quick overlook is the rock acceleration. So compared to the previous two sensors that were using geophone velocity sensors, this one is more for near field when air pressure is not required. And the benefit of this one is the high precision and high amplitude, high measuring range sensor, 14G, plus minus 14G. And this one is used for near field blast detection applications, among other things. It's also possible to use it for structural monitoring. Remember that we discussed about surrounding structures that would benefit for that. And again, we'll see an example just afterwards. So the main advantage on that is the autonomous monitoring. This could be really standalone devices that would operate 24/7, that you see on the left, with unmanned people. So you don't need to pay attention to the people, just you install the equipment and then it will work for ages without any human interaction. So that has the benefit that you will not, take care of one human person within the mining site, but also that you will remove the bias for multiple persons that are doing the monitoring, because it's a fixed installation. So everything will be captured exactly as it was installed, and you won't have any, different operators that may put different settings, different leveling of product, and so on. You can manage everything through the cloud, which also improve the data process and the workflow, having a clear somehow cockpit that gives you dashboards, or that gives you all the information when you're in your office or in the control center close to the mining site. And normally it's a quite simple installation, so you just install a concrete pedestal on the mine. This is also what we see on the left. And the idea is to have a proper coupling to the ground, which would be key from the ground movement to the sensor that is inside the red box here, and have the same measurements basically on the ground lateral and vertical movements. So we'll go to the 3 or 4 examples here. First one is in Chile for a copper mine, and you see on the right side that the different benches and they have collapsed a little bit with weak slope stability, and it was decided to have an extensive vibration monitoring around this site and also around the mining site to understand what's happening. So this is what was built, these kind of stations that you've seen also previously. You see the logger, that's the red box, the battery, and the solar charger, that is the blue box here. And everything is installed on 2 separate concrete pads to avoid, generating vibrations by the solar panel that may be moving with the wind, compared to the sensor that is separate from it. And in this site, there was 8 install station designed that way to really understand what's happening on a mining site 24/7, and also understand the scaled distance and the peak particle velocities, vector sum, and the frequency content of the mine. There's another example here in Indonesia. Also vibration monitoring with the similar motion recorder that you see here for a tailing storage facility. So there were 2 devices with a velocity sensor, and you see the protective housing and the solar panel just behind that would also monitor 24/7 of all shear velocities and all movement of the tailing structure, also for the earthquake risks in this case. So that's the second example. Third example would be a blast hole verification, and this is an underground mine that you can see on the left side with this graph. The yellow dot is this device, the rock acceleration that is stick to the wall, and near field in this case was considered as 60 meters from the blast sites with WebGen explosives. And the idea here, by capturing the vibrations, gives something like that. And this is the vector sum over time, right? It's a time history signal. And when you zoom in, that's the right side of the plot, you can match the delay of the different charges, 360 milliseconds, 365 milliseconds, and so on. So 15 milliseconds delay. And you check that you get amplitudes here after the blast to make sure that the detonator fired properly. And This is a very a good thing to optimize and automatize the process, because if you see here, for example, maybe for 1 or 2 blasts, pretty much 0 level vibration, then it would significate that you don't have any vibration generated by blast and potentially a misfire. And having the blast hole indicated here, you will be able to directly locate on your blast pattern which hole didn't exploded properly, fired properly, and then analyze further what would be the impact on the ore recovery and so on. So that would be a nice example. Last example related to far field vibration. You see on the left the equipment, the mill, the silo would be above here, and the underground mine would be at least 250 meters down these equipments. And we installed a sensor rock acceleration also here for structural monitoring, where you can monitor the mill and the silo, where you would like to protect them, as it is considered as maybe key infrastructure, sensitive structure, against any too high vibration, and maybe try to put some measures in place to avoid failures of these equipments. So that would be 4 examples that relates to what could be monitored on the mining sites. And now Javier will explain how to process this kind of data, acquired data, through the EnviroTrack solution, and make the most out of it with alarm notification and point of interest. Javier, I'll let you follow up with that. Thanks.
Thank you, Bart. I'm going to start presenting myself. Just a bit about my career in Orica. So I'm currently a product owner for BlastIQ Insights, which is a digital solution developed and owned by Orica that allows us for digitalized quality control and quality assurance of the blasting process. So in order to present how we have integrated these measurement technologies into our current suite of digital solutions powered by the Insights platform, I would like to share with you which is our digital vision, and that guides all of our current efforts. So Orica's digital vision, to summarize, is, please go back a little, Bart, to the previous slide. Thanks. To deliver an integrated suite of end-to-end digital workflows to enable Orica to sustainably mobilize the Earth resources. The key word in this phrase is integrate, as with our efforts with this, the measurement technology has been directed into getting the information out of an isolated platform and into the BlastIQ platform solution, so we can associate each measurement obtained from this Syscom equipment into the information for each blast that is already available through BlastIQ. Next, please. I'm not going to delve that much into the whole array of digital solutions that the Orica has, because it has technologies that intervene along the whole value chain from the mine to the mill. I just want to highlight that the solution we are talking about now, which is EnviroTrack, is part of the monitoring step in the process that comes after all of the results of the mining have already been obtained. So on this monitor step, we have real-time measuring and monitoring of geohazards, which include, of course, the vibration results of blasting. Let's go to the next one, please. Okay, so to talk about a little about the EnviroTrack dashboard, which you can see in the image of the screen. So the first thing we did in order to integrate the Syscom monitoring results into BlastIQ was to create an API that allows for customizable connections to real-time and historical vibrational results. and then these results can be integrated with the BlastIQ Insights platform. This allows us to build meaningful performance summaries as the ones you can currently see on the screen. We can also review aggregated data by a selected time period or by a group of filter blasts. Just remember that BlastIQ already has all the information regarding the blasts that have been incorporated into the site platform. And of course, taking into account the need for flexibility that allows the users to see and report on the data they specifically need, giving them the options to filter the blasts and just to select the ones they need to work on right now. So as you can see on the right side of the screen, there's an event report that is very detailed, and this is the information we are currently getting from the Syscom measurement sensors through the API. This data can be associated to a blast within a minute of the vibration event have been recorded, provided that we already have information on the blast at hand. So in order to show you how the EnviroTrack dashboard works, we've prepared a quick video. So you can see here what's the main interface for the dashboard on the BlastIQ Insights platform. You can use the selector on the top part of the dashboard to filter by the created or fired date of the blast, even by elevation of the bench, or otherwise just start typing the blast name in order to get the relevant results for that particular blast. For example, the blast 007 has the result you're being shown on the screen, and this can be selected to any point of interest or multiple points at the same time if needed. We can also use the blast selector to select a different blast, maintaining the POI as point of interest references. We can also use the blast selector to select one or more blasts for which we need reporting. As you can see, that lets the data be reported on the plot graphs. And every time we start filtering and using those tools, you get a summary of how many blasts are you working with and how many of those have data, because not every blast is going to trigger a measurement result. That will depend on the vibration it will produce on the rock mass. As you can see, we have both ground vibration and air overpressure results, which are measured with geophones and air pressure microphones. We have the option of playing a little bit with the map, and as you can see on the screen, each measurement is color coded to regarding its value related to a limit that we are trying not to surpass each time we do a blast. As you can see, the green represents when everything's going well and we are well below the limit. An orange color will represent us getting closer to the allowed threshold, and a red value means we go over it. There's also a table view incorporated into the dashboard that allows for very detailed information to be reviewed and even downloaded if you need to process it in some other way that is not currently seen in the dashboard. And as you can see, there are many features that have been included. This is just we can call it the first release of the EnviroTrack dashboard, with many more features to come as they are developed. Thanks, Bart. Can we move to the next one, please? Okay, so in order to be successful in the implementation of the technology we called EnviroTrack, we go through a process that is called the Customer Success Program, or CSP for short, in which we take all the necessary steps for our implementations to be successful and meaningful for our customers. So the first week, which is the kickoff week, includes a customer engagement process in which we start discussing the needs of this implementation. How is it going to provide value for the mining site or type of implementation that needs to be done. And then we move to a site scoping study in which we assess which are the hardware requirements, software requirements, and who is going to be using the technology, because that will dictate also the training requirements as well. From them, Orica prepares a proposal that is sent to the customer and tailor-made for their specific needs. Once accepted this proposal, we move on to the next phase, which is the embed phase that covers week 2 through 8. We basically have an off-site and on-site implementation. The off-site implementation being the preparation of the hardware, purchasing, configuration, testing, and overall making sure we have everything we need for implementing on-site. And then the on-site implementation itself is in which we go to the implementation site, we do the install, we make sure everything is working well, we do some testing as well, and of course the relevant training for users to be able to work with this technology. From weeks 9 onwards, we enter the support phase, in which we provide sustained global support for our users, and finalize with an implementation review in which we go through each step of the process and review the usage with the users themselves and get any feedback from them regarding the performance and value added by our technology. So we wanted to present to you very shortly a case study of an implementation we did recently for a large open pit copper mine in Peru. As you can see in the first image, this is a very big mine that mines copper. Actually, it is among the biggest mines in the world. And you can see in the center that we have a pit, and we have marked as well the 4 monitoring stations that were installed around this pit. So each one of them serves a specific purpose. The closest one monitors the south wall, which has instability precedents. There's also 2 monitoring stations surrounding the pit that have been installed in electrical substations and make sure that the blast produced vibration does not exceed a threshold that would damage them. And the northern one is probably the most important one, as it was installed a few meters away from a public road. This is a very important road for the community, as it is also a national road as well, and it is probably the one that is monitored most closely, as the impact or damage to the road would be very, very meaningful. There's a a couple of images as well on the monitoring stations that were set up. As a side note, I could share with you that one of those stations was installed at almost 5,000 meters above sea level, and still the hardware is working properly without any issues. There's a couple of solar panels installed as well that allows for this hardware to work in remote areas without any issues. Other than that, well, I can share that these 4 stations are reporting into BlastIQ using the Envirotrack dashboard, as well as the specialized SCS webpage that Syscom has in place. So in the Envirotrack dashboard for this mine site, we have information on the blasting results, the usage of explosive, and the individual values of quality assurance on each particular borehole. And we also are now getting the Envirotrack information as well. Let's go to the next one, please. So that's what I wanted to share with you. I'm going to give back to Barth now, so he can share with you the conclusions of this presentation. Thanks for your attention.
Okay, so remote real-time monitoring is essential for gaining a clear understanding of blast-induced vibration and geotechnical hazards on the mining sites, typically for slope stability, seismic activities, which are the key and maybe the main hazard risks for the open-cut mines and the benches to avoid any critical failures. This kind of real-time permanent monitoring would provide critical data-driven and effective risk assessment, and we'll try to mitigate this kind of data-driven inputs through targeted actions and response plan. So this is basically taking decisions based on facts, which is effectively what would be required for an efficient risk mitigation. And the workflow with the integration of Syscom and BlastIQ to provide, the values from the input, the real input, very sensitive, very accurate remote input into then BlastIQ for very efficient and automated data processing makes it a very, very efficient solution for pre and post blast activities. And in fact, it's not only related to blasts, right? It's also related to the mining operations and also other seismic, maybe potentially hazards. And Syscom MR2003C, BLA and ROC devices with acceleration or velocity sensor are ideal instruments for that, as they are very easy to use and very highly connectable for critical mining infrastructure. We've seen some example with communities, some ore silo, maybe mills around the mining sites. Javier mentioned a critical road that would close the communities if they cannot access this. So this is very important to monitor that with vibration devices, probably coupled with other geotechnical instrumentation when required. All right, thanks for your attention. Again, thanks, Javier, for your presentation as well. And I think now it's time for the maybe potential questions. So don't hesitate to write us at info@syscominstruments.com or contact your usual contacts within Orica Digital Solution. Thank you. All right, we have a first question. In our project, peak ground acceleration, PGA, is important as we compare the blast with seismic events, earthquakes. It's easy to explain to community, and we use the modified Mercalli scale as reference to this intensity. Can the instrument register peak ground acceleration rather than calculate it from the vibration reading? Can it work with seismogram? Yes, so it's possible. In fact, it depends on which type of sensor you are getting. It could be typically vibration velocity sensor that would provide directly vibration measurements for peak particle velocities in comparison to traditional standards, typically the ISE standard. But if you're looking for more seismology related, maybe geotechnical related applications with S-wave, P-wave propagation and so on, then we also have acceleration sensor that would give you directly the intensity and the peak run acceleration on site. So back to another questions. I'm taking them, on top of the list first. In general, what vibration readings level will affect a concrete structure? So that would be more related to frequencies. If you have high frequencies, that will not probably affect the structure, because a large concrete structure, let's suppose a dam, for example, has probably natural frequencies around 1, 2, 3 hertz. When you look at the slab, it would be 10, 15, 20 hertz. So if you have higher frequencies, you won't have too many risks of getting into a resonance effect that would potentially damage the structures. So usually the structures would be more inclined to risks and damages to lower frequencies and then of course depending on the amplitude, but lower frequencies is key. Next one. Just a second. Maybe, and Javier, feel free to jump in if you want to answer a question as well. How manage?
I actually have a couple of questions as well, so I'll let you finish before I start.
Okay, sorry. I'll take another one and then I'll let you answer to one. How do we manage the data transfer for rock acceleration located inside a mine gallery? So this is a good question. The rock acceleration operates with 4G LTE Cat M1 network, and it requires 4G access. So typically this is a device that has an internal battery that can operate as a standalone. So you would position the device on the underground, wait for the monitoring, record automatically the blast, and then post blast recover the device and bring it up above ground to transfer automatically the data. We have other solutions here. When you have Wi-Fi or maybe LAN network underground, there could be an MR2003C with the same sensor that would be suitable as well. And in this case, with automated reporting over Wi-Fi. Javier, please.
Okay, thank you. So the first one we have here is, in the case study in Peru, how is the sensor connected to the soil? So in this kind of implementations for this kind of soil, what we did was drill using a tool similar to a jackhammer, drill enough of the soil so we could get to the in situ rock, and then build a small block of concrete that that solidified in that little hole. So that way it's now connected to the in situ rock, because you would find otherwise loose rocks or even soil on top of the in situ rock most of the time. And to that block of concrete, we did three additional holes and put some threaded bolts in there in order to secure the sensor, which has holes to be able to pass through the threads, and then used bolts to really fix it to this concrete block. You can then use some bolts the sensor has itself in order to level it and orient it correctly in the direction you want the measurements to be. To summarize, we just built a concrete block that is in contact and has solidified next to the in situ rock of that place, and then bolted the sensor on top of it. The next question is it possible to transfer DIN 4150 data to ISE in post-processing Envirotrack. So I understand this question is regarding vibration measuring standards. So we do not have those enabled in the Envirotrack dashboard yet. They are on our roadmap for future features development. Although I can say that the SCS webpage does have the ability to report the measurements received in both the DIN standard, the ISE standard, and many more. And it even allows you to create your own standard if you would like to do so. And when these measurements are on the web page, you can just switch between different vibration standards and compare the results against them. We do not have that on Envirotrack right now, but we do have it on the SCS web platform.
Thanks, Javier. I'm not sure we'll be able to answer all questions, but we'll do it afterwards per email to the person that posted. And I've seen some long questions that would be maybe challenging to answer to now. Just one from my side. Can the vibration loggers deliver data directly to the third-party server for data presentation, FTP transfer, without the use of Envirotrack? The MR3000 devices can push data to any FTP or maybe secure SFTP sites. That's possible. So it's more or less platform agnostic. The benefit using Envirotrack is that it's very well tested, and the workflow is more or less automated. So that's the solution we're pushing, but it works with other software platforms as well. Correct.
I received another question over email. It says, how far is the device supposed to be installed from the blast source? So there isn't really a fixed distance that is required. However, these are sensors that are used for far field monitoring and are used fairly far from the blast holes, probably 15 meters or more away. That is mostly to protect the monitoring stations from potential damage by the blasts. You would probably get fly rods that could damage your equipment if you put it too close and in the direction of the blast. So the distance and the location specific for the devices that are installed is not really regarding the distance to the blast, but the actual location of the infrastructure or specific point you intend to measure data in. So if that point is, let's say you want to measure vibration data in a community that is 200 meters away from the mine, then it would be probably 200, 250, 300 from the blast data. But since you want the measurements in that community in particular, then you would put it that sensor within the community, not because it is on a specific distance from the blast, but because that is the point where you want to get your data measured. Hope that is clear enough.
Thanks, Javier. Maybe one last question, last answer. I have one here that is more related to geophysics. So you mentioned the tailing storage facilities. Do you have the possibility of mapping underground by measuring shear wave velocities with geophones? The possibility of using passive seismic methods for characterization of materials below the surface? So it's clear that we're using geophones and acceleration sensors that are very sensitive. It's called the MS-2010 sensor. we have some partners working with the MR3003C device to calculate the shear velocity VS30 with the HV methods using ambient vibration monitoring. And the new sensors, for example, the rock acceleration has a very sensitive sensor that has the benefit also of being localized on the map and highly time synced to the GNSS to 10 microseconds. So having localization plus very sensitive sensor that is very well time synchronized, we could imagine that you position multiple sensors around an area, and then you will capture the wave velocities in passive seismic methods. But Syscom has limited experience here, and we would be glad to test that with a partner or maybe a specialist of geophysical methods. But at the moment, this is not tested that way. All right, Javier, do you want to say a final word?
Well, there's a final question that should be quick to answer. So it says that does API integration mean subscribing to SES webhooks or a specific API? So there's a specific API that not only provides information on alerts, but also the results of the event and some other data that allows to properly connect the information to the BlastIQ blasts. So that is the that would be the answer. There's a specific API for connecting to the SES platform. So it's not really exclusive to BlastIQ, but it can be used by other services as well to connect data as long as it is able to read the information.
Correct.
Yep.
All right. So thanks, everyone. We will get the questions per email, and we'll respond in the next days to all your questions if it wasn't answered now. And again, thanks, Javier. It's being late in Australia now, and thanks for your attention during this webinar. We both remain fully available, and don't hesitate to contact us in the future for any questions. Thank you. Have a good day.
Thanks. Bye. Thanks for your attention and time.